Hello, my name is Roger with CodeRU, and in this video we're going to be discussing async and why you should care. In order to understand async, though, we kind of have to understand a bit of the history. There's been a lot of people who have asked, hey, I've already know promises, so why should I care about async and await? As you can see here, there's a Stack Over. I've seen plenty of posts on Stack Overflow or even Reddit that kind of ask the similar question as why they should care. What do async await give us that promises don't already do? So, but in order to first, to dive into that, we need to go back to the beginning and understand the earliest forms of async processes, which will be using callbacks. So callbacks was the simplest possible mechanism for handling asynchronous code in JavaScript. Yet raw callbacks sacrificed the control flow and exception handling and function semantics that developers are familiar with in asynchronous code. So here you'll see that in this example, they're using read file. This is basically designed for Node. So they've imported the file system package, and they're using the read file function off of that file system package, and to basically read in file1.txt. And as you can see here, they have a comma and then a function that they're passing as a parameter. So in here, you'll see that error is handled as a parameter, much than they do the same way in this example. So let's dive in. I have an example over here that shows using function as a callback, for a fetch URL. So as you can see here, we're retrieving the URL, which is a JSON payload. And then what we're doing is we're parsing that payload into JSON itself. And then we're exporting that out. And as you can see here, we do have the result from that. And what we're going to do is we're going to try and parse that JSON again a second time. And what that's going to do is that's going to cause an exception in the callback. So what we did is we added a try catch around here. So as you can see, it caught. So we have try catch error outputted out, and then along with the call stack. So you can see here, this is what the call stack would look like. So there's the function name, process fetch URL, and then the JSON parse error. Now, once we exit out of that, where the workflow is going to continue because we caught that exception, and we're going to run parse JSON again on the same variable. And some might expect that, hey, we have a try catch around here already as well. And so this is going to catch that error. But as you can see here, that error was not caught by the outer try catch. So that's what they're talking about in the article, where it says you sacrifice exception handling. Because in those callback functions, you have to specify the try catch in order for them to work. It doesn't work across scopes. So, but what does promises give us on top of callbacks? So promises, as a whole, allows us to do an asynchronous operation and then be able to chain a series of events onto that asynchronous call. So as you can see here, they do the asynchronous method, which returns a promise, and then you can say then. Let's look at an example over here. We're using fetch. This fetch returns a promise for us, and then we can chain a series of then statements onto it. So what'll happen is the response from this will be sent to the first then statement. Okay, we have the response, and we want to say return the JSON from that. Now the response from this is then going to be sent to the next then statement. As you can see here, we are actually exporting that value. But what we're going to try and do is we're going to send that value that's returned here. This is actually not going to be a string or anything. It's just going to be like a null value, because console log really doesn't return anything. Maybe a Boolean statement. But we're going to try and convert that. We're going to force an exception here. So that, as you can see here, we have a promise caught error because the catch statement was triggered, along with the stack trace saying JSON was undefined in response. Now, what if this catch wasn't here? Let's go ahead and try and run that. So as you can see here, what happened was that there was a unhandled promise rejection warning triggered because an error occurred within the promise, within this then statement, but there was no catch process or catch statement to handle that error. So that's what causes these kind of situations. Okay, and then you might get an error like this, saying that you're throwing it inside a function without a catch block, yada, yada, yada. Okay. So going further down here, you can see how they discuss in this article about how you can chain a series of events so that way you can kind of keep the workflow going. So that's one of the benefits promises have given us. Now let's go back to what we're here for, discussing async await. Oh, and actually to kind of go back, promises themselves was actually introduced back in 2014. So a lot of browsers, not just Node.js, actually support using promises within your JavaScript already. If you want to support older legacy browsers like Internet Explorer that doesn't support promises, then you would have to use a transpiler to be able to give that functionality in. I have another video that covers that topic, so if you're interested in that, feel free to jump over to that video to kind of get a bit of an understanding about transpilers, polyfills and transpilers. So going back to our discussion, async await. What does async do? So putting the keyword async before a function tells the function to return a promise. If the code returns something other than a promise, it will automatically wrap the resolved variable with a promise. So that way it would look like this. So, okay, in this example here, they're using async function odd number return 7. So this will return a 7, but it's going to be a promise wrapped with the 7 as the resolve output. So it will actually, in essence, look like this function here. Okay. So what does await do? Await is a keyword that simply makes JavaScript wait until the promise settles and then returns its result. Okay, so if you were to say await for the odd number, what's going to happen is it's going to say let result equal await odd number. And then once the promise resolves for odd number, it's going to store 7 into the result. So I have a bit of an example here. Okay, this is going to be based on our earlier, where we're pulling from using promises, but instead we're going to actually use async to actually do this. So I have a function here called getData, and that's going to be an async function. And we're going to say return fetch, the promise for fetch, and then we're going to then convert that result to JSON. So as you can see here, we've ran the code, and we have the try catch here, and we'll say constant JSON equals await getData with the URL. And you can see we have now the result of the JSON. It was outputted out. Now, what would be the result if we were to introduce an error into this process? So as you can see here, we'll rerun it, and you see the try catch here. We didn't need to create a catch statement here. Okay, we didn't have to define one. We were able to catch that using the try catch that was defined here in the scope. Okay, so let's take a look a little bit at async await. Async await is somewhat of a newer technology, a newer standard. And that was introduced in 2017 as opposed to promises, which was in 2014. So as Chrome actually added it in late 2016, but most of the other browsers supported it in either 2016, 2017 timeframe. Again, with async await, because if you want to support legacy functionality, you can use polyfills and transpilers to be able to fill that void for IE, since IE 11 didn't support that technology. So going back to async await. So as you can see here, they have a example of an even number. Okay, so they define the promise, and then they're saying await the result of this promise, and then store the 8 to result, and then echo it out. So that's basically just like our example that we had up here. Okay. Now, so why bother? Why care about using await and async instead of over promises, for example, if you already know it? So the answer to that is better error handling. So you can actually do a try catch using, see, like, actually it's basically what I mentioned earlier when I showed you the example. When you use promises without async, you have to define the catch statements. So async simplifies that by allowing you to wrap it around the whole scope. Let's actually jump over to a more extended example that I've written here. So in this example, we're going to do a database interaction. So I'm kind of mocking that database interaction here in code. And what I'm going to say is I want to find a movie, then I want to take that movie and I want to add some categories to it. Then after the categories are added, I wanted to add some actors. After the actors are added, then I want to save it. And then once that's done, cool, let's get a message out saying that we saved. And as you can see here, that's exactly what happened. Now, what happens if we were to, like, say, introduce an error into the save call stack? Okay, we'll rerun that. And you can see that it says that the caught save movie error was triggered along with the call stack. Okay, now let's say if we were, again, to get rid of this, let's say we were to get rid of this catch here, what would happen? Because we have catches on the upper scopes. So if we were to run that, let's try that again. Now, as you can see, we have an unhandled promise rejection warning. Okay, that's bad. That means that this error was not handled appropriately when the movie save errored out. Okay, so let's see how this would translate. So as you can see, it's a lot of nesting of functionality, especially if you want to do asynchronously. If you want to do multiple asynchronous calls in a row, it makes the code look rather dirty. So now let's take a look at how this code would look in an async await format. So as you can see here, I have the same movie declarations, but what I did is I added async in front of all these. Okay, in order to basically generate, it basically say, okay, if these values, if the return value is not a promise, it'll automatically wrap it in a promise. So if we take a look at the code, we have one try statement, one try catch here. And then this is all that we're simply doing is we're saying, let's retrieve the movie and we'll await for the result for that. Then we'll add our categories, but we're going to wait or await for that operation to complete. Then we're going to add the actors and await for that to end and then save. Okay, and as you can see here, we did that operation. Now let's introduce an error into this. Let's say we want to reject the save. What will happen? Okay, and with promises, you would have to have a catch clause on the promise in order to get it to show up. So if we take a look, we introduce the reject on the save, and now it says it's triggered the catch and try error here, along with our stack. So it definitely simplifies it. Instead of having to, like in our previous example, we had to define catch so many times in order to make sure that every promise was handled appropriately. But instead, we were able to create one try and be able to handle all of the errors that could have been reduced or introduced by this. So like if we were to change this to actors instead of the save operation, you can see here, now it says it failed to add actors, and it was all handled under the same try catch. So going back to the article, let's see here. You can, just like chaining, I explained that already about how you can do multiple async in a row. Error reporting, how it simplifies the error reporting. Now let's kind of jump down here over to the end. It discusses in this article the memory requirements, the lower memory requirements when using async over promises. So it says this is an extension of the error reporting function above, however, with more attention to the performance and memory efficiency. In this example, you can see that they created an anonymous function called foo, and boo actually returns a promise, which then calls do. So when foo is called, the following happens synchronously. Boo is called, returns a promise, then the callback, if effectively calling do, is called or is added to the callback chain. Because after that, we're done executing the code of the function. But note, foo is never suspended. This function here is never suspended, and the context is gone by the time that the asynchronous call boo is resolved. So the stack trace should include foo, since that's where the boo and do were called from, right? Well, how's that possible now that there's no reference to foo anymore? That's exactly the same case we had in our third step above. Okay, so to make it work, if you were to use async await, foo would at this point be paused in its execution. It would hold that context open. So it would have it's sufficient to store the pointer from boo to foo during the execution. Foo is suspended, so its context is still available. If boo throws an exception, the stack trace can be reconstructed on demand by traversing these pointers. If do throws an exception, the stack trace can be reconstructed just like it would be for asynchronous functions, because there will still be within foo when that happens. So that kind of goes back to our extended example. That's exactly what happened in this case. So if you remember in our original callback example, okay, when we ran this callback, okay, after it gets to this point right here, okay, after it runs the fetch URL, the scope is done with this. And so when this callback process fetch URL is called, it no longer has the stack. It no longer remembers where it was called from. So then whenever you throw an error, when you try to do the try catch around here to catch this error, that's why it fails. Okay, then going over to promises, okay, the try catch never actually errors. Actually, no, that's the await execution. My apologies. So over here, you see, we had to define this catch statement for it to even, like handle the error. The try catch in this instance, just like the callback, lost scope and then wasn't able to resolve in the try catch. And that's where async really helps. So that's it for this video. If you liked the contents, please feel free to like, subscribe. Links to the articles that I used and the code will be available in the description below. Have a good one.